Our next topic is the Kirchhoff's laws. So these laws are more comprehensive than Ohm's law and are used for solving electrical networks which may not be easily or readily solved by the latter, by the Ohm's law. So Kirchhoff's laws are particularly useful in determining the equivalent resistance of a complicated network of conductors and B for calculating the currents flowing in the various conductors. So the Kirchhoff's laws has two important laws, the Kirchhoff's current law or the Kcl and the Kirchhoff's voltage law. So first we will discuss the Kirchhoff's current law. So in any electrical network, the algebraic sum of currents meeting at a point or junction is 0. So as we discussed earlier, a node or a junction is the meeting of the common meeting of branches. Here we have two figures, figure A and B. We have a node here, node A. So I1 is entering, I2 is leaving, I3 is leaving, I4 is entering, I5 is leaving. So formulating this equation, it is the sum of all the current entering into the node. So I1 plus I4 so yan lang. It is equal to the sum of the current leaving. So I5 plus I2 plus I3. Okay? So we can say also that I1 plus I4 is minus I5 minus I2 minus I3 is equal to 0. So dapat yung mga masosolve yung values ng currents I1 to I1, I2, I3, I4, and I5, pag sinubstitute nyo dito, it will equal to 0. So for figure B, we have again node A here. So current entering is I, positive. Leaving currents are I1, I2, I3, and I4. So we have minus I1 minus I2 minus I3 minus I4 is equal to 0, or I is equal to I1 plus I2 plus I3 plus I4. So, ganyan lang yung principle ng Kirchhoff's current law. So, next one is the Kirchhoff's voltage law or the KVL. So, it is just the algebraic sum of the products of currents and resistances in each of the conductors in any closed path or mesh in a network plus the algebraic sum of the EMFs in that path is 0. So from here, as we can see, it is the sum of the products of currents and resistances. So what is the product of current and resistances? It is the voltage in each of the conductors in any closed path. So it is the voltage drop of a resistor in a conductor plus the algebraic sum of the EMFs or the sources in a path is 0. So in a closed loop, all the voltage drops and the voltage source in a given circuit, so you add them all, it is the Kirchhoff's voltage law. So from here, it is the summation of IR or the drop in your resistances plus the EMF summation of voltage sources is equal to 0. Consider this figure to illustrate the KVL equation. So we have here a circuit. Letter A. These are the nodes or the junctions. And R1 is one branch, another branch, and between three branches is the node or the junction. So we will isolate this one, detoy. So if we perform KCL in this node, as we can see here, the direction of currents, I1 is entering into the node, I2 is entering, and I3 is also entering. So I1 plus I2 plus I3. So there is no leaving currents. So we will equate it to 0. Okay, that is the Kirchhoff's current law. In Kirchhoff's voltage law, we will take one loop. Example, this loop. So if we take a loop at this point, we will have a voltage drop at R5, which is V5, voltage drop at R6, which is V6, R7, which is V7, and V8, which R8, which is V8. So if we will consider first the sum of the voltages counterclockwise order. So counterclockwise. Mangrugit tayo kani V5. So the motion of the loop is counterclockwise. So we will have current entering to the negative sign of the V5 or R5. So you have a rise in voltage. So you will have a positive here. And then after this branch, next is the V6, which has a negative sign here. So current again entering to a negative sign of V6. So you will have a positive sign of V6. Then again negative, so you will have a positive V7, V8 entering into the negative sign of V8, so that is positive V8 is equal to 0. But if we will consider current clockwise direction, mangrugita ito'y V5. So your current entering to the positive sign is equal to the fall. So you will have a negative sign of voltage drop V5. Same here. V8, siyempre the positive V8. So you will have negative. Then positive again. Positive entering to the positive sign. So that is negative V7. And then negative. Positive of V6 entering. So you will have a negative. Negative kuma detoy. Negative. This is negative. Negative V6 is equal to 0. Okay. So this will be the reference in the sign of your EMFs. So these are the voltage sources. So from point A to point B, the rise in voltage, if you have a direction of current entering into the negative sign of the source voltage, you will have a positive voltage. But if you have a current or a motion entering into a positive sign of a battery, you will have a negative voltage. So there will be a fall in voltage. This will be the reference in considering the direction or the sign of a voltage drop in any resistor. So if our motion here is the same direction with the current, you will have a fall in voltage. So the voltage drop across this resistor is equal to negative. So you will have a negative IR. But if your motion is in opposite direction with the current, Okay, so you will have a positive direction or positive sign of your voltage drop in this resistance. We will illustrate KVL and Kcl, Kirchhoff's theorem, in this example. So this is a simple series parallel circuit, and we can solve this one using current divider theorem and voltage divider theorem. But we will try to solve this one by Kirchhoff's theorem. We will assume direction of currents. Pag hindi ko binigay yung direction of current, so you will assume the direction of currents. Okay? So for now, I will give. Since this is a single source voltage, all the currents will be to the right. So this one is I1, I2, and I3. And also, we will label our circuit kasi dun tayo mag-loop. So let's say this side is A, B, C. Since there is no resistor in this path, we will make this as 1. So we will name this node as D. So we have two nodes, B and D. Pada lang data, uran ito pag KCL. So we will take now the Kcl equation at node B. Kcl equation at node B. Entering is I1. It is equal to I2 plus I3. So that's it. Next, we will now ready to formulate our KVL equations. So first loop is, we will consider KVL at, since A tayo mag-i-start, A din tayo mag-i-stop. Okay, so let's take this loop, closed loop, A, B, D, and A. So this is a closed loop. Pag hindi nyo nilagyan ng A dito, so that is open. Okay, I will not consider pag hindi kompleto yung path na i-consider nyo sa KVL equation. So we will now consider the signs of your drops, voltage drops, and the EMF. So from A to B, the motion now is from A to B. So A to B, the motion A to B is the same direction as your I1. So A to B is to the left, and also your I1 is to the right. Yung AB is to the right, and yung I1 mo is to the right. So same direction. So that means you will have a negative sign of your drop in R1. So I1, R1. Next one is BD. So BD. Motion is BD. Same direction with I2. You will have a negative I2, R2. Next is DA. So from point D to point A, our motion entered into a negative sign of the battery. So, pag negative sign siya pumasok, yung motion natin, you will have a positive source. So, plus 12 is equal to 0. Okay? Substitute lang natin. So, negative R1 is 2. 2I1 minus R2 is 4. I2 plus 12 is equal to 0. Next loop. So, may tatlong loop tayo dito. This loop, ito, at saka yung nasa labas. A, B, C, D, A. Formulate natin yung equation ng B, C, D, B. So, KVL, B, C, D, B. BC, walang resistor, so walang drop. CD, so same direction with I3, you will have a negative 6 I3. DB, so opposite direction from D to B, nagsinabat ni motion mo kan ni I2, so you will have a positive 4 I2 is equal to 0. So the last loop is outside. So KVL at A, B, C, D, A. From A to B again, negative 2I1, BC 1, CD negative 6I3, last one DA entered into a negative sign of the battery, so you will have plus 12 is equal to 0. So eto lang yung sakop ng Kcl and Kvl. The rest is mathematics, algebra. Okay? So you will use or you can use substitution or elimination, depende na sa inyo. So from here I will use substitution. I will use the Kcl. Of course, you need to use this one. Incorporate Kcl in Kvl. We have I1, I2. So if we will substitute I1 here, you will have 2, 3. And 2, 3 ay nandito na. 2, 3. So this will be my equation 1, equation 2, 3, and 4. So I will substitute equation 1 in 2. Substitute 1 in 2. So negative 2I1 minus 4I2 is equal plus 12 is equal to 0. So if I will substitute I1 or I1 in this equation, it will become negative 2 times I1 is I2 plus I3 minus 4I2 plus 12 is equal to 0. So simplifying, negative 2I2 minus 4I2, that is negative 6I2 plus negative 2I3, so this is negative 2I3 plus 12 is equal to 0. So I will get any of these, I2 or I3. So kukunin ko na lang yung I2. I2, yakar mo diba, ngirambalin na positive, so you will end up 12 minus 2I3 divided by 6. So this is my equation 5. Substitute now your equation 5 in equation 3. We'll have negative 6I3 plus 4I2. I2 is 12 minus 2I3 divided by 6 is equal to 0. So simplifying this equation, we will multiply both sides by 6 para makancel yung denominator. So 6 times 6, negative 36 I3 plus 4 times 12 is 48 minus, so cancel na yung 6 dito tsaka yung multiplier doon. 4 times 2 is 8 I3 is equal to 0. So I3 negative 36 minus 8 I3 is equal to negative 44 I3 plus 48 is equal to 0. So, I3 now will be equal to 48 divided by 44. That is equal to 1.091 amperes. Positive yung lumabas na answer natin. So that means our assumed direction of current here is correct. So, pababa yung direction ng current ng I3 natin. Solving now for I2, dun tayo sa equation 5. I2 is equal to 12 minus 2 times 1.091 divided by 6. So, I2 natin is equal to 1.636 amperes. So, positive na naman yung nakuha nating I2. So, that means correct yung inassume natin na direction ng current. Last one is your I1. Dun tayo sa equation 1. So, I1 is equal to I2 plus I3. 1.636 plus 1.091. So, I1 is equal to 2.727 amperes. Therefore, our final answers will be 2.727 amperes, 1.636 amperes, and 1.091 amperes. So, they are positive lahat. So, correct yung inassume natin na direction of currents. Pag may nag-negative dito, it means yung inassume natin na direction of current is mali. Okay? So, hindi nyo na dapat ulitin pa yung equation. At least alam mo na example, si I1 ay naging negative. Ito na lang I3. Ang nakuha natin ay negative 1.091 ampere. Example lang to ha. So, negative 1.091 ampere. So, it means, ang corrected na direction of current natin dapat ay pataas. So, mag-OR tayo dito, or 1.091 ampere upward. Okay? So, since positive lahat, so correct lahat yung inassume natin na direction of currents. So, next example. For the circuit shown in this figure, find the voltage between point C and point E. Also at point A and point G. So, paano natin masosolve yan? Given this circuit. So, as you can see, may label na yung circuit natin. A, B, C, D, E, F, G, H. Ang kulang na lang is the direction of current. So, since this is positive, negative, yung current natin is from negative to positive. So, clockwise. Since this is one circuit, we will name it as I1. Okay? And then, ito yung positive niya, ito yung negative. So, counter clockwise. So, let's say this is I2. And then, we will rewrite this circuit na lang para makita nyo yung direction ng current dito sa gitna. I redraw the circuit. So, from A to B, ito siya. BC. Walang nagbago dito. And then, etong H at G, nasa taas na. 10 volts, nandito. GF, so eto siya, 40 volts. So, mali itong polarity. Dapat negative yung nasa taas, positive yung nasa baba. F, naka-attach sa positive ng voltage. So, dapat naka-attach din siya dito. Then, FE, 8 to. So, GH, 7, HE is 5. Now, we will set the direction of currents. So, from here, ABCD, will have a clockwise direction since our current is from negative to positive yung direction niya. So, we will name this as I1. Ito, from negative to positive, so clockwise direction naman dito. Clockwise, okay? Clockwise. Then this one, from negative to positive. So, you have a counterclockwise. But kung nakiding current is that direction na. So, we will name this sa example na binigay ko sa handout. So, this is I2. And eto, walang pangalan yung current. So, it is just the loop kasi open circuit to. Walang current na dadaan dito sa point CE. Okay? So, now, isolve muna natin yung I1 using KVL. So, summation, let's say you have a loop KVL A, B, C, D, A. Okay, so you will have a negative voltage drops at 6, 5, and 9. Negative 6I1 minus 5I1 minus 9I1. And then the motion and the current is entering into the negative side, so plus 20 volts. Now, you will have negative 6, negative 5, negative 9, so that is negative 20I1 plus 20 volts is equal to 0. So, this is equal to 0, don't forget. So, solving for I1, you will get 1 ampere. 1 ampere positive. So, that means correct yung in-assume natin na direction ng current. So, dito naman sa I2, we'll have a KVL loop at H, G, F, E, H. So, same direction ang motion and direction of current, kaya negative lahat yung drops natin. So, negative 8 plus 7 plus 5. Same is true here. Negative lahat yung drops natin kasi same motion, same direction of current. So, this is I2. Entering, yung current mo entering into the negative sign of the battery. So, that is plus 40 is equal to 0. So, 8 plus 7 plus 5 is 20. I2 is equal to 40 divided by 20 is 2 amperes. Okay? So, ang required natin is VCE. So, paano natin isosolve yung voltage dito? Point B and point E. VE. CE pala, sorry, CE. Point C and point E. So, para makita natin yung voltage dito, we will use a voltmeter, diba? Voltmeter to measure the voltage between point C and E. So, we will use a voltmeter, VCE, VCE. Ito. By the way, to solve for the voltage between VCE, it is equal to the voltage at point C minus VE. So, positive yung VC. So, this is positive. This is negative. So, we will take a look at this. VCEHB. Okay? So, it is equal to KVL. So, KVL at VCEHB. Okay? So, what will be the drop in your 5 ohms? So, from B to C, same direction sa loop current natin. Ito. So, we will have a negative sign of voltage drop at 5 ohms. So, ano itong voltage drop dito sa 5 ohms? So, since the current flowing in 5 ohms is equal to I1, you will have a voltage drop at 5 ohms equal to negative of 5 I1. The loop current is entered into a positive sign of VCE, so that is negative VCE. Then EH, so same motion and same direction of currents, negative 5. Again, what is the current here at 5 ohm resistor? So you have I2 minus 5 I2, then HB. So HB from negative to positive, so you have plus 10 is equal to 0. Substitute the values of I1 and I2. Negative 5 times 1 minus VCE minus 5 times I2 is 2 plus 10 is equal to 0. So, solving for VCE, you will get negative 5, negative 10, plus 10. So, plus 10 cancel, you will have negative 5 volts. Negative sign here shows that C is negative with respect to point E. So, I redraw again the circuit. Same dito. Yung circuit dito, rinedraw ko lang dito para makita natin yung VAG. So, this is our voltmeter, VAG, to measure the voltage between point A and point G. So, I consider the counterclockwise direction since I will take my loop from A to G. So, formulating the equation of the KVL. So, KVL at loop A, B, H, G, A, B, H, G, and A. So, 6, negative 6. I1, current flowing in 6 ohms is I1 times 1. my motion entered into a positive sign of a source, so that is minus 10. And then same motion again, Hg with the direction of current. Detoy. So 7 minus 7 times current flowing in 7 is I2, which is equal to 2 ampere. And then this direction of current entered into a negative sign of VAG, so that is plus VAG is equal to 0. So VAG now will be equal to 30 volts. So we will have another example. So we have example number 3. This circuit is what we call a pi circuit kasi kaslang orientation na ket pi. Okay? So we have 5 resistances and also 5 branch currents connected to 2 sources, 12 volts and 10 volts. You cannot solve this one using simple series parallel. So, hindi mo siya masosolve. Hindi mo masosolve yung mga branch circuit currents ito. So, that's why ito yung isa sa mga uses ng Kirchhoff's theorem to solve complex circuits. Okay, we will apply Kcl and Kvl to this circuit. So we have junctions here or nodes, node B, node C, and node E. So kaya ako linagyan ng iisang letter dito kasi pag linagyan mo ng E, F, G, H, madami na. Since wala ka namang resistances sa mga conductors na to, so you have to minimize your equations. Para ma-minimize yun, pagsasamahin mo lahat ng conductors na to into one common node. So that is your letter E. Okay, so we will take first the Kcl equations of node B and C. And also, for checking, you can also get the Kcl equation here at node E. So you will have 3 Kcl equations, node B, node C, and node E. So Kcl at node B. Node B, so you have I1 is equal to IA plus I2. Kcl at node C, you have I2 is equal to IB plus I3. Last one is Kcl at E. So you have 4 branches. Ito, IA, then IB, I3, and I1. So leaving yung I1 mo. So I1 is equal to entering IA, IB, and I3. IA plus IB plus I3. So formulate now your KVL equations. You have several loops here. A, B, E, A, B, C, E, B, C, D, E, C. Okay, madami yan. A, B, C, D, E, A. May A, B, C, E, A, B, C, D, E, B. Ado, data. D, C, B, E, D. So, for lahat ng mga equations na na-formulate mo, na KVL and KCL, you can use those equations in solving the branch circuit currents using algebra Okay? So, hindi mo lahat magagamit yung mga na-formulate mong equations. Yung mga relevant lang. So, for me, I will take my KVL at loop A, B, C, E, and A. So, KVL at A, B, C, E, A. So, etong mga directions of currents na to, ay inassume ko lang. Okay? So, your assumption is maybe not the same with my assumptions. Pero, at the end, magkakapareho yung mga values na makukuha natin. Ang hindi lang magkakapareho ay yung sign. So, it can be negative to you, positive to me, positive, negative to me, positive to you. Pero yung value niya is the same. Okay? So, I will have a look at A, B, C, E, A. A, B. So, same motion, A, B, and direction of current. And then, the sign here will be negative. So, negative 2I1. BC, same again. Minus 4I2. CE. So, same again. So, negative 3IB. And then, EA. So, my motion is entered into a negative sign of a battery. So, plus 12 is equal to 0. Okay? So, this will be my equation. Ito yung gagamitin ko na nodes, B and C. So, this will be my A, equation A, equation B, and equation C. So, formulating now another loop, B, C, D, E, B. KVL, B, C, D, E, and B. So, I will get same direction 4I2 minus 6I3 then minus 10 then this is 1. So, from E to B, opposite na sila. Opposite yung IA at saka EB. So, that is equal to positive IA equal to 0. So, my last loop will be outside the circuit. A, B, C, D, E, and A. So, KVL, A, B, C, D, E, and A. So, I will have an equation equal to negative lahat kasi same yung motion tsaka direction of currents. So, negative 2I1 minus 4I2 minus 6I3. Then, minus 10 plus 12 is equal to 0. So, simplifying this. So, this is my equation D pala. Ito. So, negative 2I1 minus 4I minus 6I3 plus or yakar ko jabangir, so that is equal to negative 2 volts. Now, you will use your algebra to formulate, or I mean to solve the branch circuit currents. This is equation E. So I will substitute equation B in equation C. Ito. Substitute B in C. So I will get negative 2I1 minus 4I2 minus 3IB. IB is equal to, ito IB. So IB is equal to I2 minus I3. So I2 minus I3 is equal to negative 12. So equation E, equation F. Ay, hindi muna equation F. Simplify muna natin. So that will become negative 2I1 minus 4 minus 3I2, so minus 7I2. Then negative, negative, positive 3I3 is equal to negative 12. Okay, so this is my equation F. So I will again substitute equation 1 in D. Equation A in D. In D. So my equation A, ang kukunin ko dito ay yung IA. So IA is equal to I1 minus I2. Hindi yung I1 is equal to IA plus I2. So A in D, what is our equation D? Negative 4 I2 minus 6 I3 minus 10 plus IA is equal to 0. So I will substitute equation A, negative 4 I2 minus 6 I3 minus 10 plus I1 minus I2 is equal to 0. So simplifying this equation, it will become I1 minus 5 I2 minus 6 I3 is equal to 10. So this is my equation G. Now, kompleto na ako. Etong E, F, and G. So, using basket method or Cramer's rule, masosolve ko na simultaneous yung I1, I2, and I3. So, dun sa binigay kong example sa inyo, na sinolve ko, I use the elimination. So, you can use elimination, substitution, depende sa sa strategy nyo, kung paano nyo masosolve yung mga branch circuit currents. So now I will show to you how to solve in Cramer's rule. We are now going to solve the branch currents I1, I2, and I3. After formulating our equations here, E, F, G in terms of I1, I2, I3. So, lahat naka I1, I2, I3. So, this is the Kramer's rule. You can watch it in YouTube kung paano to. Kasi, I will not explain further here. So, parang yung basket method. So, here are the resistances, the coefficients of the I1, I2, and I3. And the other side of the equation is the constants or our voltages. So, for the determinants, we will solve the determinant matrix of R112, R32, R33. For I1 prime, we will substitute the values of the constant in the first column, and then yung second and third column, yun pa rin, hindi nagbago. Same in I1 or I2 prime. Same here in I2 prime. Yung first column is R11, R21, and R31. Second column is yung constant. Third column, R13, R23, and R33. For the I3, so this is a 3 by 3 matrix. First and second column are the coefficients of the currents, and the third column is the constants. So, final answer will be, this will be the values of your I1, I2, and I3 currents. So, I1 prime divided by the determinant, I2 is equal to I2 prime divided by the determinant, and I3 is equal to I3 prime divided by the determinant. We will now substitute the values of our equations in the matrix. So, D is equal to, what is our R11? It is equal to negative 2. R12 is negative 4. R13 is negative 6. R21 is negative 2. R22 is negative 7. R23, 3. R31 is 1. R32 is negative 5. And R33 is negative 6. Okay? So, this is equal to the sum of the products of the diagonal minus the sum of the product of the upward diagonal. Ito, nagpababa. Ito. Diyan. So, ito. And then, yan. The other one, mamaya na yung isa. So, it is the sum of the products, negative 2 times negative 7 times negative 6 plus negative 4 times 3 times 1 plus negative 6 times negative 2 times negative 5 minus so 1 times negative 7 times negative 6 plus negative 5 times 3 times negative 2 plus negative 6 times negative 4 times negative 2. So simplifying this, it will result to negative 180. So this is the value of our determinant. Next one is our I1 prime. So I1 prime is equal to our constants. So yung mga constants dun sa equation natin are negative 2, negative 12, and 10. So negative 2, negative 12, and 10. Then, ikawin natin yung column 2 and 3. Negative 4, negative 7, and negative 5, negative 6, 3, and negative 6. So if we calculate this one in our calculator, you will end up getting negative 726. Try to solve this one. Next is I2 prime. So it is equal to first column is negative 2, negative 2, and 1, and then our constants negative 2, negative 12, and 10. Third column is negative 6, 3, and negative 6. So that is equal to if we will input the equation or matrix I2 prime using scientific calculator. So mode 6, 1, and 1, 3 by 3. Negative 2, negative 2, negative 6, negative 2, negative 12, 3, 1, 10, and negative 6. So, after you input, press AC, and then shift 4, 7 for determinant, then shift 4 again for matrix A, 3. So, that is equal to negative 18. Negative 18. Let's try I3 prime. So I3 prime is equal to first column the same, -2, -2 and 1. Second column same again, -4, -7, -5, and third column is the constant, -2, -12, and 10. So we will input it in our calculator. Mode 6 1 1. So first determinant is -2. First coefficient pala, -2, then -4, -2, -2, -7, -12, 1, -5, and 10. So after mo na input, click AC, shift 4, 7, shift 4, 3. So that is equal to positive 194. 194. So solve na natin yung values ng I1, I2, and I3. So I1 is equal to I1 prime divided by D. Branch current I1 is equal to -726 divided by D is -180. So that is equal to, so same dun sa binigay kong solution or answers sa PDF. I1 natin is equal to positive 4.032 amperes. So positive means tama yung inassume natin na direction ng current. Next is I2 equal to -18 divided by -180. So that is equal to 0.1 ampere. Next, I3 is equal to positive 194 divided by -180. So that is equal to -1.078 ampere or 1.078 ampere to the left. Solving for IA is equal to I1 minus I2 and IB is I2 minus I3. So IA is equal to I1 minus I2 and IB is I2 minus I3. So that is equal to 4.032 minus I2 is equal to 0.1. 4.032 minus 0.1. 3.932. Dito pala. 3.932 amperes. Positive means correct direction of current. IB is I2, 0.1 minus I3. I3 is equal to negative 1.078. So that is equal to 1.178 amperes. Okay, so your final answers will be I1, I2, and I3, IA, and IB. So if you want to get the voltage drop across each resistors, you will just multiply I1 R1, I2 R2, I3 R3, and so on and so forth. In your exams and activities, you can use the Kramer's rule, pero gawin nyo to. Gusto kong makita yung solution. Hindi yung basta nyo na lang ilalagay yung sagot dito. Or you can use the long method, the substitution, and the elimination. Depende sa inyo kung ano yung mas prefer nyong gamitin. Okay?